All right, so question number 1, the graph of a parabola. So let's highlight that one. A parabola has x-intercept at -3, 0 and also 1, 0. First question is that we have to find the equation of the axis of symmetry of parabola. So one thing that we know is that a parabola will look something like this or something like this. Axis of symmetry is the line that divide the parabola into two same sides, left and right. Now, if you see, if we put, let's say we put this one here into the Cartesian coordinate like this, then we will see that actually the axis of symmetry is passing the x-axis. In this case, this one here is the axis of symmetry is the x of the vertex right here. So if we can find the vertex, then we can actually find the axis of symmetry. Now, another way to say this one here, since we know the x-intercept and the x-intercept, it means these two are the x-intercept, and it's also the axis of symmetry, meaning that the distance between the x-intercept going to the middle or to the symmetry is going to be the same. So we can actually find the simplest way is that we can actually just find the middle between the x-intercept. In this case, the middle between the x's, -3 and 1. Okay, so we can actually just find it. -3 plus 1 divided by 2. It's going to be -2 over 2. It's going to be -1. So the axis of symmetry is actually, the first one is x equals to -1. Okay, this is the first way that we can find the axis of symmetry. Second question. Question B. An equation for the parabola can be written in form y equals to ax squared plus bx plus c. Okay, it is the form. Given that the parabola passes through 0, -6, find the value of a, b, and the value of c. Now, we want to have y equals to ax squared plus bx plus c. We already know some things. We know the x-intercept, and we also know the y-intercept. Which one is the y-intercept? It's actually the 0, -6. And the x-intercept is -3, 0, and also 1, 0. And now, remember that C is always the y-intercept right here. Why? Because if we substitute y-intercept, the x is going to be 0. This will be gone. This will be gone because x equals to 0. So we ended up having y equals to c. So we can actually define that first c equals to -6. Okay, so now our equation for now is y equals to ax squared plus bx minus 6. Now, what should we do next? We can actually substitute the x-intercept into the equation. Okay, so first let's substitute -3, 0. What will this give us? It's gonna be y equals to 0, right? So it's gonna be 0 equals to 9a minus 3b minus 6. So this is what we will have first. And then we can also substitute 1, 0 right here. Meaning we will have y equals to 0, same thing. And then we'll have x equals to 1, so it's just going to be a plus b minus 6. Now we can solve this one here with simultaneous linear equation. I will multiply this with 3. Okay, so it's going to be 3a plus 3b minus 18. But then, in order to eliminate the b, I will add all of this. So this will be gone. It's going to be 12a. And then minus 24 equals to 0. This will make a equals to 2. And then let's substitute this a equals to 2 right here. And also c equals to -6. I'm going to write it again. We'll substitute this 2 right here into our equation. Any equation is fine. I'll substitute it into the first one. So it's going to be 0 equals to 9 times 2 or 18 minus 3b minus 6. Solve it. It's going to be b equals to, we have 18 minus 6, which is 12. B equals to 4 right here. So finally, our answer is going to be y equals to, what is the a again? Oh, I missed the a. A equals to 2 and then b equals to 4. 2x squared plus 4x minus 6. This is our equation of y. And that's question number 1. All right, question number 2. The diagram below shows a curve with equation y equals to 2 plus k cos x defined for the axis between negative pi over 2 all the way to 5 pi over 2. All right, so we have the equation right here, but we're missing the k. Then we also have the range, sorry, the domain of the function here of the equation. Now, the point S lies on the curve and has coordinate of negative pi over 3, 7 over 2. And then we have the point T with coordinates A, B, which is the minimum point right here. Okay, all right, now let's see. The first question is to show that k equals to 3. So basically here we need to find what is k. Now, our equation is y equals to 2 plus k cos x. So always start to work with what we have here. Since we have to find k, it's basically like this. If you know the y and x, any y and x, then we can find the k. Now, thankfully, we are given y and x right there, which is this one here. X for this one here and y for this one. So we can actually substitute these values into our equation. So it's going to be 7 over 2 equals to 2 plus k times cos negative pi over 2. Now, for some of you who are not really familiar with using pi, you can change that pi into 180. So this one is going to be negative 180 over 3. So it's actually going to be negative 60. So I'll rewrite this as degrees. K times cos negative 60 degrees. Now, how do we find the value? Remember, this is paper 1. You cannot use calculator to find the value of the cos. So this is one of the special angle. So actually, you have to be able to memorize the value of the special angle, sine and cos of the special angle. But I will use the graph of the function. So since we have the cosine function right here, so you have to know that the graph of cosine function will start from 1 and then it will go down like this. Okay, so this is 0 right here, and this is the 90, this is 180, and so on. Now, since we have negative 60, it means we are going backwards. How does the calculation work? It works the same way as you are going to the right side. So right here is going to be this direction. Okay, it never goes beyond 1 or negative 1. So in this case, which one is negative 60? So since we have 0, then it means right here is going to be negative 30. This one is going to be negative 45. It means where is our negative 60 is going to be somewhere right here. And then it's going to be this one here. So the y, it's going to follow the same pattern as the normal cosine rules. So in this case, since we're a little bit closer to 0, which is cos negative 90, meaning that cos negative 60 is going to be 1 over 2. Okay, so from this one, we got cos negative 60 is going to be negative 1. Oh, sorry, not negative, but it's going to be positive 1 over 2 right here. So that's what we substitute here. Let me write it here. So we have 7 over 2 equals to 2 plus k times, what do we have now? 1 over 2. I'll write it k over 2. It's better if we don't work with fraction actually. So I will multiply everything with 2. So now we will have it as 7 equals to, each one of them is multiplied with 2. 7 equals to 4 plus k, meaning that 7 minus 4 equals to k, we can say k equals to 3. And that's it. That's how we get k equals to 3. So now our equation becomes y equals to 2 plus 3 cos x. Hence, find the value of a and the value of b. Now let's go to that one. We already have our equation as y equals to 2 plus 3 cos x. So now, let's find the value of a and b. A and b is a point T and is the minimum point. How do we find the minimum? We know the minimum right here actually has a gradient of 0, meaning that we can actually find it using derivative. Finding minimum and maximum, we can find it using the gradient or dy dx equals to 0. So first thing first, we have to find what is dy dx. Derive it from the y is going to be dy dx equals to 2 will just be 0. I'll not write that one. And then we'll still have 3. Cos x is going to be negative sine x. Okay. So since the dy dx is going to be 0, it means we are substituting the dy dx with 0. So it's going to be 0 equals to negative 3 sine x, meaning that sine x equals to 0. Now, what are the x's that will give us 0 from this range right here? What do we have? It's going to be x. Well, first, we can actually take the negative pi over 2, right? The 90, and then we can also have 0, right? Oops, yeah, sine x. My bad, this is not cos, this is sine. Okay, so sine x equals to 0, meaning that x is going to be 0. And then we can also have it as 180 degrees. This is going to be pi. And then we can also have 360 degrees, which is 2 pi right here. Why do we have to list everything? Look at the x that is possible here. Again, let me highlight this one here. 0, 180, 360, okay? They are all included in the domain right there. But the one that we have here is going to be t, right? So not x, not when x equals to 0. So the next one is going to be when x equals to pi or 180 degrees. So this is the one that we will use for our x. Now, how about the y? Just substitute this one here into our x. So now we'll have y equals to 2 plus 3 cos 180. What is cos 180? We can actually use the function right here. 0, 90, 180 is going to be negative 1. So we will have y equals to 2 plus 3 times minus 1. At the end, it's going to be 2 minus 3. So the answer is negative 1. So that's it. That's our a and b. The a is going to be 180 or pi, comma, negative 1. Okay, so let's go to question number 3. Let's read it again. A geometric series. Okay, so we know geometric series has a positive common ratio of r. Okay, so we know that the ratio is going to be positive. Okay, so it means it's going to be bigger than 0. And then the series has a sum to infinity of 9. Okay, another information here. We have sum to infinity equals to 9. And the sum of the first two terms is 5. Okay, so it's S2 right here equals to 5. Now, the question is find the first three terms of the series. Okay, so we want to find what is U1, and then what is U2, and then what is U3 right here. That is our question, not the sum right now. The first 3 terms right here. Okay, so this is the information that we can use to solve our problem here. So let's start from defining what is U1, what is U2, what is U3, right? So, well, U1 is just the first term, right? And then U2 is basically is just U1 times the ratio. So if we know what is U1, if we know what is the ratio, then we can find what is U2 and also U3. Okay, so our objective here is to find what is U1, what is U, and what is R. All right, now our first information, we know that as infinity or sum to infinity equals to 9. We have the formula for this, okay, in the formula booklet, right? Sum to infinity, the formula is we have A or U1, right, divided by 1 minus R right here. Okay, so we can substitute this sum to infinity with 9. Let me erase and substitute this with 9. So this is what we have first. Can we do anything to this one here? You can multiply the 9 with 1 minus R, but let's keep it like this for now. Okay, right now, second information, we have S2 equals to 5. Now, S2 is actually the addition of U1 or A, right? I'll put it as A, U1 and also U2, right? So what can we do right here now? We know that U2 is, we can actually get U2 from U1, right? U2 is actually just U1 multiplied with R right here. So if I substitute the U2 is going to be 5 equals to, I will also substitute U1 with A plus A times R right here. Now, if you see, now we have two equations with two variables, meaning that it's solvable and it's going to be simultaneous linear equation. Okay, so what will be here? I will multiply the 9 with 1 minus R equals to A. So then later, I will change all of the A right here with 9 times 1 minus R. Okay, so it's going to be 9 times 1 minus R. And also this A right here. This A is going to be, now this is the tricky one here. I will multiply the 9 times 1 minus R first. So it's going to be 9 minus 9R multiplied with R. Okay. All right, so next one is just algebra. So 9 minus 9R plus 9R. I'll multiply the R, okay, with everything on the inside, 9R, and then minus 9R squared right here. Okay, all right, so now what do we have? We can eliminate this one here. And then we can also have, oh, let's see right here, 5 equals to 9 minus 9R squared. Okay, I will change some things a little bit here. Step by step, it's going to be negative 9R squared plus 4. And then I will change it like this. 9R squared minus 4. Now, this is an algebra trick, right there, especially for quadratic. Okay, I hope you still remember this one here. When you have a squared minus b squared, this is actually a plus b times a minus b. Okay, this is the multiplication, expansion that we know. Now, this one here, 9r squared and minus 4 can actually be expressed as 3r to the power of 2 minus 2 to the power of 2. As you see, the form is exactly the same as that one right there. Meaning that we can continue this one here as 0 equals to 3r plus 2 and then 3r minus 2. All right, now we have two options for our r, meaning that we can have 3r plus 2 equals to 0. Meaning that we have r equals to, I'll do it quick here, negative 2 over 3. Or the second one, we can have 3r minus 2 equals to 0. Meaning that r equals to 2 over 3. Now we know that the ratio is going to be bigger than 0. Okay, so we reject this answer here, but we take r equals to 2 over 3. Okay, that's the r that we know. We also need to know our a. I will just use this r into the sum to infinity. So let me put it right here. So it's going to be 9 and then 1 minus 2 over 3 equals to 8. All right, just fraction, okay, simple, 9, and then this is going to be 3 times 1, 3 minus 2, 1 over 3 equals to A, meaning that our A is going to be 3. Okay, we got the A and we got the R, so we can find U1 equals to 3, U2 equals to 3 times 2 over 3, which is going to be 2. And then lastly, we have U3 equals to 2 times 2 over 3, meaning we have it as 4 over 3. That's it. 1, U2, and U3. Okay, on to the next question. Next question. Find the equation of the line that is normal to the curve y equals to 3x plus e to the power of negative x at the point where x equals to 0. Okay, all right. So we want to find an equation of the line that is normal. Now remember, to find normal, we have to find the tangent first. We don't need to find the whole tangent line, but we can actually just find the gradient of the tangent. Okay, we need that to find the gradient of the normal. Now, how do you find gradient of a line or gradient of the tangent? Is basically by dy dx. Dy dx of what? Of course, of the equation right there. Okay, so we have to find the dy dx. Our y is 3x plus e to the power of negative x right here. And now, let's derive this one here. We find dy dx. Derivative of 3x is just going to be 3. Derivative of e to the power of negative x. Now, be careful. This is not e to the power of x, but this is e to the power of negative x. Basically, the short way is that we can derive this one first. It's going to be -1. So it's going to be -1. And then we derive this as a whole, which is still going to be e to the power of negative x. So this is what we will have here. 3 minus e to the power of negative x. Let me erase the 1. E to the power of negative x. Now, let's see what is the gradient at x equals to 0, meaning that we have to substitute x with 0 right here. So the gradient is going to be 3 minus e to the power of 0. Now, e to the power of 0 is not 0. Be careful. E to the power of 0 is 1. So 3 minus 1 equals to 2. Now, this is the gradient of the tangent. We want to find the gradient of normal. Remember that tangent and normal are 90 degrees. So this is, if this is the tangent and this is the normal here. So it means the gradient is going to be the total opposite. Now, what is the total opposite? Not just the dy dx, not just it's going to be -2. No, not only that, but it will also reverse the 2. So it's going to be -1 over 2. Okay, so this is what we call the total opposite of 2. Positive becomes negative, and we will flip the number. So now, this is the gradient of the normal. So this is what we have to use into our y right here. Y, this one right here, it represents the equation of normal line for now. Okay, so our equation is going to be y equals to -1 over 2x plus c. Remember the general formula for straight line. Now, what we need to do is to find c. How? If we know any x and any y, then we can find the c. Now, do we know any x or y here? Remember that in our normal, we don't really know any points, except for one point. We know that normal is passing through the same point as tangent. So let's say we have this curve here, and then we have a tangent right here, this one here, and then the normal is passing through the same point right here. So if we know this point here, then we can actually use it for our y and x of the normal. So how do you find this one here? We know that this is when x equals to 0. Now, what is the y? Remember, this point is also part of the curve. Y equals to 3x plus e to the power of negative x. So we can substitute actually x equals to 0, substitute into y equals to 3 times 0 plus e to the power of negative 0. 3 to the power of 0 is just going to be 0, and then e to the power of negative 0 is just going to be 1. So y equals to 1 right here. So when x equals to 0, y equals to 1. This is the point that belongs to the tangent line and also belongs to the normal line. So substitute y equals to 0 and y equals to 1 and x equals to 0. So it's going to be 1 equals to negative 1 over 2 times 0 plus c. That's it. It means c equals to 1. So our equation, our final answer is going to be y equals to negative 1 over 2x plus 1. That's it. Is our answer. On to the next one. Next question, solve for x in each of the following equation. All right, so this is a logarithm equation. So right here, now the key for logarithm is that you must have the same base. This one here is the same base right here. Okay, yeah. So let's go with the first one here. First one, so log 2 and then 5x squared minus x minus 2 equals to 2 plus 2 log 2x. Now, if you notice in every equation, you have to be able to simplify first. Okay, that's the thing. Now, if you see on the left side, you cannot really simplify anything on the left side. So what can we do on the right side here? On the right side, we can, the first property of logarithm is that if you have like a coefficient in front of the log, you can actually bring it to the back, right here. It belongs to the x. So I will change this one here into log 2x squared. And then secondly, you can also change the 2 right here into log 2. Now, it's basically like this. Log 2, we know we will write it as log 2. So log 2 what equals to 2? Right, that is our question. Log 2 what equals to 2? Now, it means the question is 2 to the power of 2 equals to what? Meaning that this one is going to be 2 to the power of 2 or 4 right here. Okay, so the 2 right there, we can write it as log 2, 4 right there. Okay, so now after we change it into same base, log 2, remember we can combine. One of the properties is that if we have addition with the same base, we can multiply the inside, the 4 and also x squared. So meaning that we can rewrite this as log 2, 4x. That's it. This is what I meant by simplifying first. So now since they're already the same, we rewrite them. So it's going to be like this, 5x squared minus x minus 2 equals to log 2, 4x squared. Now, since they're the same base left and right, so what can we do? We can just equate the inside, meaning that it can be written as 5x squared minus x minus 2 equals to 4x squared. And then this is going to be a quadratic, meaning we have to make it 0. X squared minus x minus 2 equals to 0, meaning that we can also factorize this one here. Equals to 0. What will it be? It's going to be x minus 2 and x plus 1. Okay, now we have two possible answers for x. We can have x minus 2 equals to 0, meaning that x equals to 2. Or we can have x plus 1 equals to 0 or x equals to negative 1. Which one is the correct one here? Now, if you see, we can have two answers. Okay, it means we have x equals to 2 and also x equals to negative 1. Okay, that is for question B. Okay, next one for question B. Now, we want to express that equation in the form of ln A and ln B. Now, this is a tricky one here, okay? But if you cannot really see what on or how to do it, try to do what you can do first. Okay, so right here we have 3x plus 1 equals 2 to the power of 2 minus x. Now, what we can do is that we cannot change it into same base, not yet, okay? But we can actually simplify this one here, right? So 3x plus 1, meaning that this actually comes from 3 to the power of x times 3 to the power of 1. And this one here, 2 to the power of 2 minus x, this comes from 2 to the power of 2 divided by 2 to the power of x right here. So what we can do is that we can actually combine the x's. Remember, our goal is to solve, meaning we want to find what is x. Put all the x together. So we can have it as 3 to the power of x times 2 to the power of x equals to, okay, I'll change it into 4 over 3 right here. And then it's going to be 3 to the power of 2 to the power of x right here equals to 4 over 3. Meaning that's going to be 6 to the power of x equals to 4 over 3. Now, it means we can change it into logarithm base. X equals to log 6 and then 4 over 3 right here. Now, how can we make it into ln? Remember, ln meaning that we make it into a new base. Okay, so another property is that we can just change the base, right, into ln. So it's going to be ln 4 over 3 over ln 6 right here. That's it. We can make it like this. All right, question number 6. Let's read the question first. The coefficient of x squared in the expansion of 1 plus x to the power of 2n and 1 plus 15x squared to the power of n are equal. So the coefficients of this are equal. Given that n is a positive integer, find the value of n. All right, now we have to know what kind of combination that will make x to the power of 2 for each one of the expansion. Okay, we are not going to open the whole expansion, but we are going to just look at the x squared. So this is where you have to know the combination that needs to be used right here. So for the first one, we have 1 plus x squared, meaning that the terms that we have is going to be 1 and then x right here. Now, what will give us power of x right there? Sorry, power of x squared. It means if x has power of 2 right here. It means what will the power of 1 have? The power of 1 will have 2n minus 2. Let me write it again right here. X to the power of 2. How about the combination? The combination that we will have from the total of 2n, we'll take 2. So this is our combination for the x squared. And then how about for the second one? The second one, the term that we have is 1 and also 15x squared. Now this one is already 15x squared. So it means that we only want it to be 1. And for the 1 right here is going to be n minus 1. So what's the combination? Same thing with the first one. The combination from the total of n will only take 1 right here. So this is the combination that we will have for each. It means that let's expand this all. Now I will cancel this and this because 1 to the power of anything will just be 1. So let's go with the combination. The combination is going to be 2n factorial divided by 2 factorial and then multiply with 2n minus 2 factorial. And then we don't have the 1 and then we have x squared right here. As for the second one, we will have n factorial divided by 1 factorial. We can ignore that one later. and we have n minus 1 factorial. Multiply with 15x squared. Now, we'll just focus on the coefficient because the coefficient is the one that is the same. Now, let's try to work with each one of it first. How should we work with this one here? So remember, if we want to have 2n factorial here, if we expand the factorial, what will we have? We will have, let me write it here, if we have 2n factorial, it means we will have 2n times 2n minus 1 times 2n minus 2. Now this will keep going, right? This will keep going. It means we can stop here and write it as 2n minus 2 factorial. Now if you see, it's actually the same with the denominator. So if I'm going to write it down, I'll write it 2n times 2n minus 1 times 2n minus 2 factorial divided by 2 factorial and then 2n minus 2 factorial. Now, if you see, we have the same one right here. So we can actually cancel this and also this. So this is the manipulation that we can do for factorial. So same thing with the one that we have right there for n factorial. We can expand it, okay? We can expand it so it becomes n times n minus 1. Now we can stop it right here. We can have it factorial right here, and then it's going to be the same with the bottom one. I will not write the 1 factorial anymore, so it's just going to be n minus 1 factorial. We can actually simplify this two. Equal times 15x squared. Now, what will we have here? Now we will have 2n multiplied with 2n minus 1 divided by 2, and then we have x squared. And right here we have just 15n, right? Yeah, just 15n right there. 15n times x squared. Let's just focus on the coefficient. They are the same. Let me use another color here. We will have, I'll multiply it directly. So we have 4n squared minus 2n divided by 2 equals to 15n, right? So what will we have? I will multiply the 2 with 15. So it's going to be 4n squared minus 2n equals to 30n. Okay? Meaning that we will have 4n squared and then I'll have minus 32n equals to 0. Now let's factorize what we can factorize. First, I can take out 4n right there. So we will have n minus 8 equals to 0. We can have 4n equals to 0, meaning that n equals to 0. Or we can have n minus 8 equals to 0, meaning that n equals to 8. Which one makes more sense? Of course, not n equals to 0. So our answer is going to be n equals to 8. That's question 6. Let's move on to the next question. Next one that we have, question 7. Again, always start by reading everything. In a class of 16 students, so the total of 16, 12 study math. Okay, it means everything on this group, including the middle one, is math. And then 6 study physics, and 2 study neither mathematics or physics. Oh, meaning that we know what's outside. What is outside of the circles right there. So this one is 2. Okay, all right. The class is represented by the diagram below, A, B, C, and D. Calculate the value of A, the value of B, the value of C, and the value of D. So one thing that we know is that D equals to 2. Okay, if D equals to 2 means that everything that we have on the inside is going to be 14. So A, B, and C are going to be 14. Now, if we see 12 study math, so it means right here, A and B is 12. Okay, A plus B is 12. Yeah, I'll write it outside here. And then we have 6 study physics means that B and C study physics right here. So this is 6. Now, if you see, it's supposed to be 16, but then we have how many? 18 right here. There are 4 more. Now, here's the logic. If we add 12 and 6, meaning that we add A plus B, right? And we also add it with B plus C right here. Now, if you add these two, we'll actually add B twice right here, right? If we have 12 and 6, we will add B twice. It means we have one extra B right here. And remember, what is our extra? Right here, 18. Our extra is 4 because it's supposed to be 14. Meaning that that extra is actually the middle. That extra is actually the B. So we know that B equals to 4. How about the A? Well, the A, it means it's just 12 minus 4. 12 minus the middle one, meaning A equals to 8. And then our C is just going to be 2 right there. The total of this is 14. Okay, all right. So that's our answer for A, B, C, and D. Okay, let me write it here. So it's visible 4 and then 8 and then 2. Okay, now next question, question II. A student is randomly selected from the class. Given that the student studies physics, now this is what we call conditional probability. Given that the student studies physics, show that the probability that the student also studies mathematics is 2 out of 3. Now you can go with the formula if you want. But then here's the logic behind this question here. So we want to find the probability that the students studies mathematics given that the students is studying physics. So it means our total is just from the students that study physics. Again, it means our total is only from the students who study physics. So we're not taking it from the whole population here, but then only from students who study physics. So only from 6 students. From 6 students who study physics, how many study math? It means the middle one here. Because the middle one are students who also studied mathematics other than study physics. So that's why we have 4 out of 6, which means this equals to 2 out of 3. Question I. 2 students are randomly selected from the class. Find the probability that the first student chosen studies only mathematics. Okay, so it is selected from the class, meaning that out of 16. So the first student chosen studies only mathematics, meaning that how many students who studies only mathematics? 8. It means the first one is going to be 8 out of 16. This is the first student right here. And then the second student chosen studies only physics. And now, when the first student is chosen, that students will not be chosen again. It means the total for the next choice, the second choice, is only 15. Now, since this is independent probability, it means it's 2 different events, meaning that we are using multiplication. So right here, the second one is out of 15. We want to get the students who studies only physics, meaning it's only 2 right here. So again, 8 out of 16 is the student who study only mathematics. That student is chosen. Now we only have 15 students on the second choice. Second choice, we want to pick the student who studies only physics, which is 2 out of 15. So if we simplify this, we have 1, 2, and then we can also simplify the 2 right there. It's going to be 1. 1 out of 15 is our answer. Okay, question B. 2 students are randomly selected from the class and moved to a different class. Find the probability that the remaining class of 14 students has no students that studies only physics. Now, based on this question here, find the probability that the remaining class of 14 students has no students that studies only physics. So we want to exclude this one here. The logic is that the first student that is chosen is the students who study only physics. And the second student was also the same, who is the students who studies only physics. So we can get that probability first. The students who studies only physics. So what is that probability? First, we have 2 out of 16. That's our first one. The student who studies only physics. Now that student is chosen, yeah. And then on the second try, from 15 students, it's also the students who studies only physics. So we have 1 right here. So we can actually find the probability of this one here, 1 and 8. So it means we will have 1 out of 90. And then, so this is the probability. The probability choosing 2 students who studies only physics. Now we want to get the opposite of this, meaning that 14 students, the other 14 students has no students that studies only physics, meaning that we want to get the opposite of this. It means we want to have 1 minus 1 out of 90. Again, the keyword is the opposite, meaning that we will have 90 minus 1 is going to be 89 out of 90. So this is the probability of the remaining class of 14 students has no students that studies only physics. Next question, question 8. Now, one thing that we have noticed is that the marks usually represent the number of time that is suggested for you to solve the questions. So in this case, 19 minutes or 20 minutes for this one here. But we don't want to use 19 minutes. Okay, if possible, we can use less than 90 minutes. Now, the velocity v in meter per second, that is meter per second of an object, moving along a straight line at time t seconds is given by Vt equals to 2t squared minus 4t minus 6, where the t is between 0 to 4. At t equals to 0 seconds, the displacement of the object is s equals to 0 meter. Now, determine the value of t at which the object reaches its minimum velocity. So we have our function for velocity, and then we want to reach the minimum velocity. So this is the same thing as finding the minimum or maximum of a graph. So what to do right here? It means we have to do the derivative. So we have to find question A, part 1. So we have to find the dv dt, and then what do we need to do? We need to make it equals to 0 to find the minimum or maximum. Gradient equals to 0. Okay, so first, what is dv dt here? This is still simple for us to derive. dv dt equals to 4t minus 4. Now, this should be equals to 0, meaning that we will have 0 equals to 4t minus 4. And what is our t right here? Our t is going to be t equals to 1. Basic algebra. T equals to 1. So that's the value of t at which the object reaches its minimum velocity. Now, next one. Show that the displacement of the object at this value of t is negative 22 over 3. Now, before we move on, how do we know this is minimum and not maximum? So we can actually notice from the form of the function right here, the quadratic function. Remember, quadratic function, we will either have this one here, concave down or concave up. So only 2 choices. So either the t is right here as the maximum or the t is right here as the minimum. Now, since we know that the coefficient of t squared is positive, meaning that we know that is going to be concave up. So we will only have one stationary point. It means it's going to be minimum. Okay, so we don't need to check on that one. Now, part 2. that show that the displacement of the object at this value of t is negative 22/3 meters. Now, what is displacement here? Remember, when we talk about kinematics, this is what we call kinematics. Vt, or what do you call that, velocity, if you derive, we will get acceleration. But then if we integrate this one here, we will actually have displacement, or sometimes we call it distance. So how do we get the displacement? Is that we have to integrate 2t squared minus 4t minus 6. So it means we have to find 2t squared integration of 2t squared minus 4t minus 6 dt right here. Now, we want to get the displacement of the object at this value of t. It means when t equals to 1. When t equals to 1 right here. So it means, let's integrate this one here. So we will have 2/3 t squared, sorry, t to the power of 3 minus 4 out of 2t squared, and then minus 60 right here. So this one is going to be, let's simplify, 2 out of 3 t cubed minus 2t squared minus 60. Now we only need to substitute t equals to 1 right here. Substitute with t equals to 1. What will we have? We will actually have 2 out of 3 minus 2 minus 6. Now let's work with this one here. We will have 2 out of 3 minus, this is going to be, oh, okay, 2 times 3, 6 out of 3, and then minus 18 out of 3. Okay, so at the end, 2 minus 6 is minus 4, minus 4 minus 18, yes, gonna be negative 22/3 when t equals to 1. Okay, that's it. This is our answer for A part 2. Okay, next one right here. Next question, sketch a graph. Now, sketch a graph right here. Sketch a graph of VT, clearly labeling all x-intercepts, maxima, and minima. Now, let's work with this one here. We already have, first thing first, we already have the minimum velocity at t equals to 1. So we have to consider that one there. Question D part I. Okay, so it's going to be t equals to 1 for the minimum. So minimum is when t equals to 1. You can find the v as well if you want. Okay, so it means v1 is going to be 2 minus 4 minus 6. 2 minus 4 minus 6. So we will have 2 minus 6 minus 8. Negative 8 right there. And then what else do we have that we need to find? All axis intercept. Okay, so first we need to find the x-intercept, meaning that y equals to 0. Okay, so let's try to do y-intercept first. So it's easier. Y-intercept is when x equals to 0 or t equals to 0. So it's 0, comma, always the constant at the back, 0, comma, negative 6. And then we can find the x-intercept is when y equals to 0, meaning that we will have it as 0 equals to 2t squared minus 4t minus 6. I'll take out all the 2 first, so it's gonna be 0 equals to t squared minus 2t minus 3 right here. Okay, what will we have here? We can actually have it as 0 equals to t, we can factorize it, okay, t minus 3 times t plus 1. Okay, meaning our intercept is going to be when t equals to 3 or when t equals to negative 1. Now, here's the thing. Take a look at this one here. The t is only between 0 to 4. So we take this one here, but we don't take this one because it's only between 0 to 4. Okay, so that's the x-intercept. Do we have any maxima or minima? Now, if you see, since it's bounded from only between 0 to 4, we have to check on each end. So when t equals to 0, what will be the v right here? Okay, of course, we already know that one, the y-intercept, so we can ignore this one here. So when t equals to 4, what is our v right here? So v 4 right there. So we will have 2 times, what is that? 16, right? 4 squared minus 4 times 4, and then minus 6 right there. So it means we will have 3, 4 equals 2 times 16, 32 minus 16 minus 6. It's going to be 16 minus 6 can be 10. So when t equals to 4, the velocity is going to be 10. Okay, so let's get all of the points that we need to plot right here. So first, we have 1 comma negative 8. And then second, we have 0 comma negative 6. And then third, we also have 3 comma 0. And then we also need to plot 4 comma 10. Okay, all right. So our x and y. Our x and y right here, it's supposed to be, okay, let's sketch. Yeah, so we have 0, 1, 2, 3, 4. Okay, and then we also have negative 8. As long as negative 8 right here, just put it right here, and we have 10 right here. And then it's going to be 1 comma negative 8. 1 comma negative 8 is going to be right here. And we have 0 comma negative 6. Let's say it's right here. And then we have 3 comma 0, which is going to be right here. 410 is going to be right here. So it's going to be something like this. Again, this is just a sketching, okay? Right there. So let's put everything. So right here we have 0 comma negative 6. And right here we have, which one is it? 1 negative 8. And then we also have 3 comma 0 as our intercept. And we have 4 comma 10 right here. This is actually our maximum highest point. Okay, all right. So that's the question for sketching right there. Now, the next question, write down the interval of time during which the object is moving to the right. Now, when the object is moving to the right, it basically says that the velocity, okay, the velocity is actually going up right here, going positive, okay, yeah, going positive. So it means that our velocity, the interval when the object is moving to the right to right here, it means it's between 1 until 4. So it means when the t is less than 4, okay, and then it's bigger than 1. And then the interval of time during which the object is moving to the left, it means that it's going to be when the time is between 0 and 1. So the time is less than 1, but then bigger than 0. Okay, all right, that's a simple one. Next question. Find the distance traveled by the object from t equals to 0 to t equals to 2 seconds. So remember, when we talk about distance before, it's actually the integral of the velocity. But then since we know it's between 0 to 2 seconds, it means that it's a definite integral between 0 to 2. So right here, what will we have? We will have part C right here. So we have the integral of 2t squared minus 4t minus 6 dt. But then this one is between 0 to 2 seconds. Why is the distance we need to use definite integral? It's actually the same thing as finding the area. So the area between the between the graph right there. Okay, yeah, that's how we can find the distance traveled. So in this case here, we are going to have, okay, let's cheat on the previous one. 2 over 3 t cubed minus 2t minus 60, this one. Okay, so we have 2 over 3 t cubed. Then we have negative 2t squared minus 60. Now this one, we want to have it between 0 to 2 right there. So let's substitute. So it means we will have 2 over 3, 2 to the power of 3 minus 2, and then 2 to the power of 2 minus 6 times 2. And then minus, now you can actually substitute 0, but at the end, it's all going to be gone, right? If you substitute 0 here, 0 cubed minus 2, 0 squared, oopsie, 0 squared, and then minus 6 times 0. It's all gonna be 0 at the end. So I'll ignore that one there. Let's just focus on this one here. So what will we have? We will have, what is it? 2 over 3. So it's actually similar. Is it similar like the previous? No, that one is 1. So right here we have 2 cubed, which is 8, and then minus 8, and then minus 12 right here. Now, simplify this one here. What will we have? We'll have 16 over 3 minus 8 minus 12. Okay, let's just make it all over 3. So, oops, not negative, still positive. 16 over 3, and then minus 24 over 3, then minus 36 over 3. So what will we have here? 16 minus 24 is negative 8. Negative 8 minus 36 is going to be negative 44 over 3. Now, since distance is positive, okay, then it means we have to use absolute sign right here. So it means our answer is going to be 44 over 3 meters. This is our answer here. Is it meters? Yes, it is in meters. Okay, so that's for question number 8. Next one, the diagram shows the graph of the function defined by fx equals to x times square root of 1 minus x squared, where the x is between negative 1 to 1. The graph is given right there, and the function has a minimum at point P and a maximum at point Q. Now, first question show that f prime x equals to that. So we want to find the first derivative now. Our function is going to be fx equals to x times square root of 1 minus x squared. So right here, you can actually use the multiplication rule because it's times between what? Between x and also square root of 1 minus x squared. So remember, if we want to use multiplication rule, it's going to be, what is it? U prime v. So we derive the u, and then after that, v prime times u. Okay, so let's assume that our u equals to x, meaning that our u prime or derivative of x is going to be 1. And then our v is square root of 1 minus x squared. It means what is our v prime? Now this one here, we need more work. We are going to use chain rule right here. So first, okay, first we substitute the inside here. So let's say uv, let's use w. So w equals to 1 minus x squared, meaning that if we derive w in terms of x, what will we have? We'll have negative 2x right here. And then now our v now has become, square root of w. Or I will change it, v equals to w to the power of 1 over 2. Now, can we derive this one here? Yes. Deriving v in terms of w, what will we have? It means we will have 1 over 2 times 1 over 2 times a w to the power of negative half. Meaning that dv over dw is going to be 1 over 2w to the power of half. So at the end, how do we get the v prime? And we just multiply all of the derivatives. So it means we will have 1 over 2w squared times negative 2x. I can simplify this one here. So v prime is just going to be x, negative x, over, let's change the w squared back into, oh sorry, y power of 2, power of half, right here, into square root of 1 minus x squared. Okay, all right, so let's collect everything that we have here. It means f prime x. Our u prime is going to be 1. I will not write that 1, or I will. 1 times v is just going to be square root of 1 minus x squared. And then minus v prime. V prime is going to be negative x, and then 1 square root of 1 minus x squared multiplied with u, which is x right there. Okay, so what will we have here? The f prime x. We will have it as, okay, so it's going to be square root of 1 minus x squared. Oh, I cannot combine it yet. So I will have square root of 1 minus x squared plus x squared over square root of 1 minus x squared. Now, this is like a mixed number. So we can actually multiply this. We can combine it by multiplying it and then add it with x squared. So it's going to be we'll have the denominator as square root of 1 minus x squared, and then right here we will actually have 1 minus x squared right there. Oh wait, let me check right here. Is there any mistake? Because right here, if we do it like this, then it means we will have the x squared would be gone. Is there any small mistake right here? 1 minus x squared, yes, negative. Oh, my bad. This one here, it's supposed to be plus. Okay, why do I put subtract right? So this is plus right here, meaning this is going to be subtraction, and this is going to be subtraction here. Okay, so at the end, if we combine everything, what will we have? F prime x is going to be 1 minus 2x squared, 1 minus x squared. Okay, all right. Sorry for the mistake. Let's go to the next question. Next question, find the coordinates of P and the coordinates of Q. Now, we know that P and Q are the minimum and maximum point. So how do we find it? Minimum and maximum will always be found using the first derivative equals to 0. So we already got the first derivative right there. All right. So let's use that one. First derivative equals to 0. So for question B right here, we have first derivative equals to 0, meaning that we have our first derivative, right? It means we have 1 minus 2x squared over square root of 1 minus x squared equals to 0. It means, what will we have? Right here, we will have 1 minus 2x squared equals to 0. Now, simplify, we want to find the axis right here. So it's going to be 1 equals to 2x squared. It means 1 over 2 equals to x squared. It means that x equals to square root of 1 over 2. How can we have two answers? Remember, it can be plus minus. Okay, I will make it x equals to plus minus, and then it's going to be 1 over 2 square root of 2. Now you can use this one here, or you can use this one here. It's fine. Now, but I think I'll use the first one. Okay, plus minus right here. Why? We'll see later. So we have our axis of the P and Q. Of course, this one is the positive, right? Square root of 1 over 2, and this is the negative 1 over 2. So let's try to substitute. So if we have first one, if we have f square root of 1 over 2, let's substitute. So we will have square root of 1 over 2, and then times square root of 1 minus, this is why I will use the first one there, because we will have square root of 1 over 2, and then square it right here. Okay, yeah. So what will we have here? It's still square root of 1 over 2. This is just going to be 1 over 2, right? So it's going to be square root of 1 minus 1 over 2 right there. So what will we have in this one here? It's going to be square root of 1 over 2 times square root of 1 over 2. Well, this is also going to be 1 over 2 right there. So this is for the first one here. Square root of 1 over 2, comma 1 over 2. And then for the second one, we'll substitute f with negative square root of 1 over 2. Well, the same thing, we'll have negative square root of 1 over 2 times square root of 1 minus. Now, this one will have negative square root of 1 over 2. But it will not change too much because negative and then you square it is actually going to be just 1 over 2. So we'll have negative square root of 1 over 2 times 1 minus. It's going to be 1 over 2 again. So at the end, it's going to be the same. Negative square root of 1 over 2 times square root of 1 over 2. At the end, it's going to be the same, but then we will have negative 1 over 2. So our P right there, our P is going to be negative square root of 1 over 2, comma, negative 1 over 2. And then our Q right there is going to be square root of 1 over 2, comma, 1 over 2. That's it. That's our answer for coordinates of P and also coordinates of Q. Next question. Next one, given that the function g is defined as gx equals to 2 times fx minus 3, determine the range of g. Now, it's so tempting for us to find gx because we can actually find the algebra of it, right? So it's 2 and then times fx minus 3. We can substitute x minus 3 right there and we can multiply it with 2. But then we can actually just work with transformation of function right here. Transformation of function. So if you notice what is the one that's changing from the fx there? Now, what does the negative 3 mean? Negative 3 means that we are going to the left, okay? Negative 3 right here means we are going to the left 3 steps. Okay, that's the transformation there, left 3 steps. So it means first thing first, we actually have this one here from our range of g. So let's talk about the range. So it means we will have range, we will start from the range of fx, which is from half all the way to negative half. Now, if we move it to the left 3 steps, does the y change? No, it doesn't. Okay, so the range will stay the same right there. Okay, and then the 2 right here, we multiply the 2 with f. It means what will we do? We'll actually do stretch, which stretch vertically because we multiply it with the y. Stretch vertically by 2 means that we multiply the y by 2. Now, if you see, this is the y, right? It means it will be stretched. It's going to look something like this. How far will it go? Well, we will multiply it with 2, right? So it means from half right here, we will actually multiply this with 2 and we will multiply this with 2. Meaning that our new y after it's stretched vertical by 2 is going to be from 1, 2 times half, all the way to negative 1. From 1 to negative 1. So it means this is going to be our new range right here. Okay, so gx is going to be less than or equals to 1, and then it's going to be more than or equals to negative 1. So we just need to look at it from the transformation of function. All right, and that's the end of this paper here. Hopefully you learned something new. If you have any question, please put it on the comment section and I'll see you on the next paper. See you later.